here we're going to continue with our R functions, and we're going to go into descriptive summaries of the data frame. So one of the basic one is the summary function. So this is a function. It's called summary, and you cannot name it whatever you want. It's called summary. So if you write summary with an I, it's not going to work, but because you can see a number of functions come up that do exist. COPD is the data frame that we created. So we named this ourselves. We invented this name, COPD. And then that's the input to the summary function. And we run that. And we see a summary of all of the variables here on the bottom. And what does the summary give? Well, the minimum values, the first quartile, the median, the mean, the third quartile, and the maximum value. So let's look at one that's easily interpretable, age. So the minimum age is 44, the first quartile is 65, the median is 71, the mean is 70, the third quartile is 75, and the maximum is 88. So this is kind of what we would get in a box plot. Now we are missing some other interesting summaries. So for example, standard deviation in particular, but we can get that very easily is I'll show you in a second. So if we're going to do it just for age, for example, we don't need to do all the variables. Let's just focus on age, standard deviation for a specific variable. We do SD. SD is the function, and in parentheses, we just identify the specific variable of that data set, of that data frame, and we do that with that money symbol. I don't know why they chose the money symbol, but that's the money symbol. So this is this variable of that data frame. And notice when you start typing, if you were to type it from scratch, COPD, and you put the money sign, RStudio very smartly just kind of gives you all the potential variables of that data frame. And if you start typing age and you just kind of hit enter, it kind of comes up over there. Notice that it's also capitalized, so you need to maintain the same capitalization. We run that, and then the result comes here. So the standard deviation is 7.89 for this variable. And we can also do a summary for the whole, just for the specific variable. So we see here, focus, we saw it before, but we see here just for the one variable. These are quantitative variables. If we are working with qualitative variables, we might want to use the table command and tabulate the data. So for example, if we're working with gender, we might want to see how many are female and how many are male. So 0 is female, 36, male is 65. And we use the table command for that. Other commands as well. So interquartile range, IQR command for, let's say, for age, it gives you 10. And what is this? Well, it's not very useful. I think this is more useful when you just have the summary. And you can see that 10 is really the interquartile range. Let's remember it's between 25th percentile to 75th percentile. So it's really just 75 minus 65, 10, which we could just we could see evidently right from this information right here. And also range, there's a function for range, but also we can see range is maximum value minus minimum value, so it's there as well. And let's continue here on also a kind of part 3. Let's call this part 3, assignments and data types, and I'll continue on the same video here. So note that R assumes that binary data is usually numeric. So when we have that age data over there, that's assumed as numeric because all the values are zeros and ones. So often if we're going to work with some tests of categorical data, we want to tell the program that this is a categorical data. And what we do is use this function as.factor. So there's two things going on here. First, we're using this function as.factor for gender. So this makes gender a categorical factor as a categorical data. And also we're assigning the result here into the gender variable. So here is the name we created. We could have called gender capitalized, or we could have called gender uncapitalized. So this is the name that we are giving it. So let's just call it gender. And here that puts that that variable into a new variable, now factorized as the categorical data. And we could do the same for smoking too. So smoking is a categorical variable, yes or no. The values are 1 and 2, but it's not really smoking. It's not smoking 1 cigarette or 2 cigarettes. It's just not smoking 1, smoking 2. We can assign smoking as a factor. And then we can also tabulate. We can tabulate those values, or just by using that's new variable we created. And we see smoking 116 to 85. Other interesting things we can do is you can create a new variable with a particular condition. So we have age data. But assume that we want to do some kind of categorical calculation with age, such as people above a certain age or people below a certain age. Well, we can create a new variable with a condition, with this if-else condition. So as usual, let's look at the right side over here. So we have an if-else statement, which is a function, and then we have the first is the condition. We have 3 items between the commas. The first is the condition that we want to test. So here we're going to create a variable for people that are elder, which is essentially above 70. So we're going, if the rows, the units we're observing are greater than 70, then we're going to give it a value of 1. If not, we're going to give a value of 0. This is a pretty standard if-else construct. You see this in Microsoft Excel as well. And we're going to assign these values based on this condition to this variable. And this is this kind of standard notation for assignment in R, but also if you just use equal, it works. The thing is sometimes equal has a different use as well, and people get confused. So often they use it like this, but those are 2 characters instead of 1 character. So I prefer to use it like that. So we can create this new variable in the data set. So I kind of created, notice how I put elder in the data frame that we have. So if we run this, if we run this, we create the variable, it doesn't show anything, but then if we print out copd.elder, it, not copd money sign.elder, it shows that variable, and we can, if we table that, because we only have 2 values, we can tabulate it. So 0 are 46, 1 are 55. So 55 people are elder, 46 are not elder. Now, elder, of course, is kind of ambiguous. So what is elder? So maybe we could have used another term, such as above 70. Note that usually we don't want to name a variable with a number. You see how it changed color there because of data types in computers. So if you start putting number there, it's going to think that this is not a variable name. So never begin a variable name with a number. Never begin a variable name with a number. But we can have a number in the variable name as long as we don't begin with a number. So maybe a better name would be above 70. And then we can run that. And then we write above 70. And this is kind of just way more clear, right? So 46 people are above 70, 55 people are, I'm sorry, 46 people are below 70, or equal, 55 people are above 70. Notice we just put above, so the other 0 would be, if it's equal 70, would also be included as 0 here if it's below 70 or equal 70. And because this is a binary variable, we also may want to change it. So we can say above 70 equals S factor COPD money above 70. We run that, and then it's done. Or we can also table this. Notice that we don't need to create a new variable if we don't want. We can include a function within a function. So this is one function, and it's included within the other function. And always the things in the center run first, and then in the external run second. And the assignment also, remember, always you take it from the right, you would do the thing on the right, and then you assign it to the left. So if we run this here, we'll run kind of the same thing. It looks the same, but now we tabulated and then we made it into a factor. Actually, let's see the result. If I do above 70, we did create this variable, right? I don't see it. Did I delete it? Yeah, often if you make it into a factor, they kind of put the name of the variable here, or maybe just because we're only focused on one variable and not as a variable of the data set. So either way, I'm going to leave this part for now and continue on the next segment.